I want to thank Henry Ferguson for the chance to work with him over the years and to offer his final webinar through our National Soil Survey Center webinar series. Henry is someone who has brought out the best in many of us, not only here, but across the country in his many travels. Henry, I'm going to turn the webinar over to you.
Thank you, Sean. So this webinar concerns the updates to the National Cooperative Soil Survey Soil Characterization Database, or the integration of the NCSS Soil Characterization Database in NRCS. We got to get the thing working. Okay, so before I begin the main presentation, there's some critical issues that I might forget if I get into the presentation, so I decided I'd talk about them up front. The first major issue is that when you sample something, you have to document why you sampled it. And the reason for that is that several years after you're gone, people will look at that database and have no clue as to what you did or why you did it. And sometimes, depending upon the words you use and how you document what you did, they may actually throw the data out of the database and it won't show up. So keywords like characterization, benchmark soils, those are the kind of things you want to include in your sampling if you want it to survive in perpetuity. If you don't mind it being shelved, you can put some terms like research or something that has something to do with trying to find out whether something is near a break or something. And those kind of samples, reference samples, often get dumped out of the database. So try to document why you're taking the samples and try to get representative samples. The original source for a lot of our projects are on microfiche downstairs in this office. And if our agency doesn't decide to go ahead and try to get those converted, we're going to lose a lot of the project files for the past samples that were done by this office and this lab. Currently, we actually are scanning the project files and turning them into PDF, and those are going to be invaluable resources when you review your data in the future. User pattern IDs and laboratory sample numbers are critical in the database, especially after the last few years. We've started to point to the RO-owned pedons for distribution with the lab data. And in order for those pedons to be properly linked to the database, they have to have the pedon sample numbers and the horizon sample numbers in those pedons, or you can't link the lab database to the morphological data. Depths of sampling. There's some strong controversies over what data should be kept in our database. Some people believe that if you sample by depths, the data is worthless and should be dumped. They say you have to sample by horizon. There are other people that say that it's critical to have some samples in the database by depths. So if you look back through the history of our database, you'll find some places people are very intelligent and they actually sampled the same pit twice, once by horizon and once by depths, to make sure that that data stayed in our database. So anyway, those are some of the key issues that you need to be aware of if you really want your data to stick around in the database. So there have been a lot of changes to NRCS and the Laboratory Data Mart in the last few years. You don't really realize how many there were until you start adding them up and putting them on paper. But the reason we're doing this is to try to provide the KSL data along with the morphological descriptions. We've added a taxonomic history table. We added the NCS lab pedon layer tables, which actually put some of the a subset of the lab data in NRCS, so it's more readily available. We've added depths to the pedon horizon sample table, so in the future we might actually even use NRCS for collecting the form for submission to the lab. And we've added a pedon horizon lab results table to separate the field lab information from other labs. We modified the web pedon description report so it points to the MO or RO owned pedons if one exists. We've added ownership groups by RO, and in the case of sites, we moved all of the site information to the ROs so they can manage them and manage the groups, manage who is able to update the site locations. We've added data mining reports to NASA's to be able to extract what was previously the Soil 8 information out of those RO pedons and put it into the lab database. We've added calculations to NASA's to help people update the NCS lab pedon table, the lab layer table, the horizon sample table, sample numbers, and several other features. The lab Data Mart. We changed the lab Data Mart by adding footnotes to the whole soil bulk density calculations. Some people didn't realize that some of those calculations were based on a default value for bulk density, and we've added a footnote to specify exactly when the bulk density was actually measured and when it was a default value was used. We've modified the results of the base saturation calculation not to exceed 100%. We all know that you can get more than 100% for base saturation if you have lots of calcium, but in the website, it only reports back 100%, even the calculation, though the calculation ends up with a greater number. We've added a link to the Microsoft Access database from the NCSS Soil Characterization website, and we're designing 6 new tables for future delivery. Besides the work in the center, we've also had a lot of support from the field. Over the years, Kevin Gotze has created the first download reports for Analysis PC. Jason Nemechek has been helping to keep the pedon description report up to date every time we have a new data model change. Adolfo Diaz and Jason had just finished creating a download for morphological data, which will help us link morphological data to NASA's. When we were in Informix, we were able to download up to 80 or 90,000 pedons at a time. Once we went to SQL, we've been limited to about 5,000 to download at a time into Analysis PC, and this will help us go back up to be able to download the entire database at once. Dylan Baudet, Tom DeBello, Stephen Roker, and Jay Scalvin have supported the deployment of use of R to evaluate laboratory data. And Kyle Stevens recently has updated a pedon description report to capture the new tables and data elements added to NASA's. So there's a lot of work out in the field. I'm sure I missed several people in their contributions. Well, we need to thank everybody for helping out. We released a new soil characterization data website on February 10th, 2015 with a new look and feel. That new look and feel included a link to a Microsoft Access database. And for the last couple of years, we've also rolled in a file geodatabase that Adolfo Diaz has helped create. So when you download the Microsoft Access database from the website, you also get a file geodatabase with it. We have the Google Fusion maps to help people identify where their sites are and do a little bit of QA/QC. We've got almost all of the points out of the ocean, which is nice, except for the ones that belong there, the subaqueous soils. The NCSS lab pedon and lab layer tables, they're designed to contain the most commonly used soil lab data that is used in the component table or the aggregated data. So it doesn't include all of the lab data, it just includes the most commonly used data elements for classification and for population of the aggregated data. Once again, we now can use features that the field has developed for putting our lab data into R and do analysis using free software. So for the benefit of individuals that have tuned into previous webinars, I'm going to discuss developments in reverse, the newest to the oldest changes. The newest thing we've been working on is the development of 6 new tables for delivering data. The reason we've done that is people have had problems in the past with some of the joins, so we have fewer joins. It's easier to find the desired data. We have clearer links to the methods and the metadata. And there's a clear distinction between calculations based on measured data and calculations based on estimates or default data. The 6 table names are physical properties, chemical properties, major and trace elements and total oxides, optical mineralogy glass counts, X-ray and thermal, and calculations including estimates and default values. The 6th table used to be called the supplementary tiers. What is the timetable for getting these tables out? Well, the scripts have been written. Sample tables have been generated. The data has been reviewed once. Additional reviews needed. The tables take anywhere from 1 to 4 days per table to run the queries on. And once we get them run and reviewed, then hopefully they'll get posted, and we might create a web service for them. But that's the goal. What led up to the creation of the new tables? Well, there was some misuse of the results due to misunderstandings of the methods used. We had some research papers that were going out, and they were talking about our lab database, and it was obvious that they really didn't understand how the methods had changed over the years. And so these tables will help with that. There was confusion regarding the joins between tables. We had 14 to 18 different result tables that had to be joined. There was an inability to match each result with a method. In the previous tables, we had several methods in the same column, and there was no distinction between where the results, which method was used for which results. They've been talking about a web service for several years, and it hasn't happened yet, so this may help that effort. And we need better documentation for the database distribution product. Currently, the metadata for this product is put in NRCS, and those of you that have used the Sergo metadata tables and the NRCS metadata tables, we can now generate similar tables for the laboratory database. What do the tables look like? The method code column's been added, and there's a method code next to each set of related data elements. And the column headers have been expanded from abbreviations to full text. So instead of like PSM, it'd be particle size method. A little bit easier to read and understand. In our Access database, we have a analyte procedure table that allows you to click on a link and go directly to the SSAR 42 methods manual and see where that method is used and what it is. The disadvantages of these tables are there are more columns in the table. Some of these tables are almost 200 columns wide. And the second disadvantage is that some of the column headers are very long. Some examples are bulk density third bar less than 2 millimeter for calculations. So what we're going to be looking for is for a few people to look at these kind of tables and see, are they usable? I mean, do we want to continue with them? Is it something we actually want to promote and push to its final conclusion? A lot of the headings aren't quite that long, but these are some of the longer ones. More of the advantage is that data that was never distributed before has been added to the tables. So there's different methods and analysis that have been run by this lab that have been buried in the database for years, and they've never seen the light of day. And so these tables allow us to share some of that data. Additional definitions have been added to the documentation to help the understanding of the measured values. There were a lot of values in the database that said definition to be added, definition to be added, definition to be added. And so we've actually tried to get some of those in this new product, in the new documentation. The tables themselves can help with education as they are clearer and easier to understand. They have plain English instead of acronyms. A closer look at the calculations table. In the calculations table, the first few columns include the source for the third bar bulk density used for the whole soil calculations. So in this column, you see that 1.47 is the measured third bar bulk density value, and it's identified as dB third bar. The 1.45 is the default value, and it was not measured. So that is identified with a default value. If there was an estimated value, then there would be a entry saying that it was an estimated value. This is similar to our website where we added the footnote. So in our website, there's a footnote that says whole soil bulk density was not measured. It was calculated using 1.45 grams per cc as a third bar bulk density of the less than 2 millimeter fraction for mineral soils. So we made this explicit on the website so we can tell the difference between those cases where a calculation result came from measured values and when it was from a default value. Particle density is almost always estimated to be 2.65, but here it's explicit because some people might use 2.6, for example. And when you're doing calculations for carbon for the world, it can make a big difference whether you use 2.65 or 2.6. So it's important that we're consistent and we tell people exactly how we did our calculations. So things that we've done to the database in the last couple of years include removing the default value of 1.45 for organic soils. I mean, some of those things just make our database look bad. We don't want that in there. And we also removed results using a default bulk density for 1.45 for organic soils as well as the default value. This is a continuing maintenance issue because whenever we get new data from the laboratory database, it continually will keep populating our database with more of these organic soils with a default value of 1.45 for bulk density. So they have to be manually stripped out. So for the future, I recommend that we consider the use of petal transfer functions to make better estimates for the third bar bulk density and recalculate appropriate results in the calculations and estimates table when a measured value of third bar bulk density is lacking. We've got some pretty talented people here that are good researchers, and they probably can come up with some better estimates than 1.45 in a lot of cases. More future problems to tackle. And these are future problems because they were past problems. Coarse fragments or rock fragments has been a major topic of discussion for many of our meetings in the last 6 years. How can we solve the problem in the future? If people properly follow directions on the sample submission sheet, we do not have a problem. It can be fixed. And the process is the field properly fills out the sample submission sheet. Rock fragments are entered into the laboratory database. The volumes of the rock fragments are for classes greater than 75 millimeter are estimated in the field. Rock fragments from greater than 75, or rock fragments 20 to 75 millimeters are weighed in the field and discarded, and fragments greater than 2 millimeter and less than 20 millimeter are weighed in the laboratory. All these things happen now. The lab then converts the rock fragment weights to percent weight on a 75 millimeter base. Using the bulk density, the lab converts the rock fragment weights to a volume on a 75 millimeter base and a whole soil base. All this thing happens already, what I've gotten to so far. Then number 8, the volume of the rock fragments from 2 to 75 millimeter are subtracted from the total rock fragment volume as entered in NRCS, and the volumes of the rock fragment classes greater than 75 are adjusted accordingly in NRCS in the laboratory database. So number 8 and 9 typically have not been done. But up until 7, that's basically where we stop. And the result is that we get a diagram like this. This is just a histogram showing the units are sort of off. One side is volume and one is weights. But the general thing that you can see is that in some cases, no NRCS estimates made into the laboratory database. So you got soils with 65, 75, 85% rock fragments in NRCS, and they have a 0 in the lab database. Likewise, the laboratory database may have measured some fragments, and NRCS has 0 in the fragment table. So where does this come from? It comes from the field relying on the lab to measure the fragments and not entering any fragments into NRCS at all. Sometimes people do that. They don't want to be proven wrong, so they just don't enter anything. Also, the field might enter fragments in NRCS using breaks that do not fit the laboratory data model, so no fragments made into the laboratory database. So over the years, if people put fragments in NRCS and had breaks other than gravel, stones, boulders, cobbles, if some of the people in the lab didn't know how to enter the data, they might have just left it out. So that's number 2. And the third case is somebody actually sieved the samples in the field. They had a really extremely gravelly soil. There was hardly any fines, so they sieved the samples in the field, threw all the fragments away, and only sent in the fines. So that's another case where you've got a big difference between the lab and NRCS. Why haven't these cases been fixed? It's a matter of ownership. No one at the NSSC should be messing with descriptions. The state soil scientists mandated that the sampled as or original pet-on description should be maintained as is. And I agree with that. It shouldn't be messed with. So my recommendation is that the sampled as pet-on should remain as is, and the copies of the KSSL pet-ons could be updated based upon the 9 steps previously described. So if anybody has time, they might want to try that to see if they can actually get the lab and the NASAS to balance. Kathy Seibold has written some validations for NASAS that you can use to compare the laboratory database, the rock fragments in the database to, in the lab database to the rock fragments in NASAS. After enough people tried that, then we might consider data mining to extract the revised rock fragment volumes from NASAS and then update the calculations table. So nothing's really been done on, we've talked a lot about this for years, but not much has actually been done on this other than trying to get people educated. So realistically, about 90% of the estimates are probably good enough. The most important pet-ons to catch are those with 0 for fragments in laboratory and large estimate in NASAS, or the measured value in laboratory and data in 0 in NASAS. The ones that are really obvious are the ones we ought to catch. You know, if you've got an extremely gravelly soil with 0% rock fragments, that is a problem. Why hasn't data mining taken place already? Sometimes NASAS has duplicate rock fragment data amounting to 150 or 200% estimates. That means some people need some training. They need to understand how to populate NASAS before we feel comfortable mining their data out. The first step is awareness, to educate for the future, and the next step would be to data mine once pet-ons are properly certified. So maybe if people are trained and we certify pet-ons, maybe the certified pet-ons are the ones we should data mine. If there's issues with the laboratory database, there are some impossible results in the database. There are negative values due to the detection limits of instruments. That basically means the instrument comes back with a negative, you know, against a blank, and it ends up with a negative value and ends up in the database, and we haven't stripped those out. In the website, if you go to the website, you can elect whether you want the values that are weird to come out as a dash or a trace or a null, or dashes and traces to come out null or 0. Basically what you're doing is you're converting a database that is able to hold text information like a dash or a trace. You're converting that database into a database that can only hold numbers, which is similar to what NASAS is, or this table that we're building. And so, like I say, in the website, the user has the choice. They can say, I would like the traces and dashes that become 0 or null. And if we decide to put these 6 tables out, we may want to consider making a decision and documenting what we've done to get rid of those negative results. There are also some values that just don't match the common units, such as peak heights. Our peak heights are classes 1 through 5. If you see a peak height that's a 10 or 20 or 40, that means they probably used a different class. They might have used percents or something. And so it's possible there might be some things where there's unit issues in our database. And there also is the possibility of typos. In the past, researchers ran scripts against the database to clean it up. So they knew these issues had been in the database for decades. Our goal, I believe, should be to run similar scripts against the database for these 6 tables for the general public, so we don't give them the junk that researchers already knew exist and have been stripping out in the past. Examples would be converting the bulk base saturations values to 100% and converting the negative values to zeros, etc. So basically what we want to do is we want to use those same scripts that were done long ago, or the scripts that are used in the website, against the database itself. So a little change in thought here, and we'll go back to some history related to the changes that I just discussed. Prior to 2011, the SSL Web Pedon Description Report brought back as many pedons as were in NRCS that had the same pedon sample number. So if there were 2 pedons, it brought back 2. If there were more than 2, it would bring that more than 2. As of 2011, we changed the report so it only brings back a single pedon. And preferentially, it chooses a certified pedon and one that's owned by the RO. This increased the importance of the RO-owned pedon. So in order for the report to find the RO-owned pedon, it has to have a laboratory sample number in the pedon table. If it doesn't have the sample number, it can't find the description. So what that also means is if somebody puts the pedon sample number in the wrong pedon, then it'll bring back the wrong description. So some of you may remember that several years ago I was sending out some reports, and those reports were to help you update your database. And then I stopped doing that. And there was a reason why I stopped sending those reports out. One of the reasons was because we have 2 separate databases. We have NRCS and we have a lab database. And here we're talking about the integration of the 2 databases. In SDJR, people were asked to enter pedons. They were asked to enter pedons using the sampling, the user pedon nomenclature that's specified in the field book. But they weren't in the field describing the pedon. They were in the office describing a pedon that was in a book. Right? Well, years before, people were in the field. And when people were in the field, they used the naming nomenclature to send pedons into the lab. Or even worse, they didn't use the correct nomenclature for sending pedons into the lab. Once those pedons came into the lab made up a sample number for the laboratory pedon. So you've got some pedon that comes in that says Ricky's new pedon, and it's changed to S1965 VT 02196 or whatever, right? So then years later, somebody else goes into the manuscript for that county, and they take a pedon and they arbitrarily assign another user pedon ID to a pedon, and accidentally they give that pedon the same number as a sampled as pedon from years before. So when I found out that that was happening, I stopped sending out any more reports, because I knew that some people had no problem because they consistently were using the standard nomenclature, and they would not have any problem because they would not get any duplicates. Or what, not a duplicate, it's actually a duplicate ID, but on different pedons. But those individuals that were just going into the manuscripts and starting from, number 1 and going on, there's a possibility we could have got mixed up there. So I stopped sending out those reports at that time. It's better to do no harm than to do anything. So basically, there might be a few of those, but hopefully not many, because we stopped pretty early in the process. As soon as we found out that was happening, I didn't send out any more reports. Okay, but besides the pedon horizon sample number, or pedon sample number, there's also a pedon horizon sample number. Okay, and the way those sample numbers are assigned, of course, in the lab, we assign all those numbers. And when we try to match those up to pedons that were in the database from years ago, because prior to 2011, it was a common practice to copy the pedon and copy the site from the field, and then put the sample number in the pedon that was owned by the lab, which means you now had thousands of pedons out in the database that had no sample numbers at all. Okay? As long as those pedons were copied, that's great. You join the user pattern IDs, and you make a list, and you send out a list and say, update the pattern lab sample numbers for these pattons. And then once you get the pattern sample numbers populated, then you can go and populate the horizon sample numbers under them. Okay? That's the next step. But why doesn't that always work so well? Okay, if they're identical pattons with different user pattern IDs, that doesn't help the join any, does it? So if the lab changed the ID when it came in the door, you can't join the user pattern ID. If somebody created a new pattern years later and put the same ID on it, now you've got two pattons with the same user pattern ID, but they're different pattons. That doesn't work too good. Normally, what I like to do when I join pattons to make sure I have the right pattern is I join the user pattern ID, the pattern sample number, the horizon designation, and the depths. Because then you have a lot of things that you're joining, and it's sort of like the lottery. You have a pretty good chance of getting the right one, because it's pretty unusual that you would have the wrong one if all those things matched. However, people do change horizon designations, and sometimes people change depths. Remember that in the 1980s, we changed from measuring to the top of the mineral to measuring to the top of the O. And besides that, sometimes people made a mistake when they entered their pattern, and they entered it in inches instead of centimeters, so you got one pattern in inches and one in centimeters. So those are all different reasons why it's difficult to get the sample numbers into the pattern. Besides the fact the NRCS interface is a pain to use. However, NRCS forms that are out now will help. So hopefully we can get more of those horizon sample numbers populated in NRCS now that we have a better interface to use. So in the future, how can we make sure that these sample numbers are all line up between NRCS and the lab? Well, it's pretty much the standard procedure we've talked about for a while. The field soil scientists make sure that they have the same sample number on the description as they do on the bag. That's a really good thing to have happen. You change the ownership from the RO, or Soil Survey Office, to KSSL so we can put the sample numbers on for you. Okay? And you change the site to your RO so you can keep managing the site location. Once you've done that, that's when you would make the copies of the pattern, after we've already put the sample numbers in. Okay? Now remember, a few years ago, management decided it's important to maintain an original sampled as pattern in NRCS. And for these new pattons, that is fine. We can probably do that. The question is, how many original pattons are really in NRCS? Probably not too many, because the older pattons were described in English, and we converted them to metric. The depth of the top of the soil was changed from the top of the mineral to the top of the organic. In some cases, you have a pattern that had an O horizon, and it's in the description that they had an O horizon on the paper copy. But they kicked the O out of the way, and they correlated that pattern, as the O said, without an O horizon. So those things can happen too. We might want to try to get those O horizons back again. Over the years, horizon designation have been modified to keep up with standards. Many of the attributes were previously recorded as classes and were stored in NRCS as numbers. So they used to be few, common, many. Now they are 1, 2, 3, 4, 5. So redoxomorphic features were added, and many models were reclassified as redoxomorphic. So there's a lot of pattons that really are not the original pattern that was sampled in the first place. That is a true statement. And some pattons were correlated or updated before they even were entered into NRCS, because it's a lot of work to enter a pattern, so who wants to enter two? So most of the time they would sort of correlate the pedon as they went. If they didn't like the designations, they would change them, an A2 to an E, before they put it in the database. Prior to 2010, there was no taxonomic history table in NRCS, so if classifications were updated, the previous classification was overridden. Okay. Recommendations. The taxonomic history table has been maintained in the lab database for a long time, and I imported most of those classifications into NRCS, into the lab pedons. So we have captured those classifications, a lot of them that had been wiped out. And the NCSS lab layer table was added to NRCS. So now that we've got the NCSS lab layer table in NRCS, you can actually store the original horizon designation as well as the new one. We can't store intermediate ones, but you can at least store the very first one and the very last one. But this is a good example of some of the things I've talked about previously. So this is what the database looked like this morning. We had a designation, a current designation of BTK1, and we had an original horizon designation of BTN1. That seems sort of strange, because when we went to the lab on the web, from the website, it was a BTK1, and the BTK1 is the lab database, which is the database that's least likely to be updated. So the next step is to go to the scan project. So this is the project that they actually scanned, so we know that that was archived from the time the project was started. So now we can tell from the scan project that the original horizon designation was a BTK1. And so I went to NRCS and verified that the current pedon has BTN1, and I updated the NCSS lab layer table to reflect what I found, which was that the original designation was BTK1 and the current designation is BTN1. That took a while. There's 388,000 or more samples in the lab database. So you can pretty much bet that most people aren't going to have time to spend that much time on a pedon. So it's best to try to keep the database straight as you go instead of trying to search out problems after the fact. That one just happened to catch my eye because I was looking for an example for the webinar. Another example of why you should be careful of bagging and tagging in your samples. A few months ago, we had somebody contact us about two pedons. One was a fine silty soil, I think, and one was a clayey soil. They had a fine silty description, but the lab data was clay. They had another description that was vice versa. So it took somewhere on the order of 16 to 18 hours of people's time to review all the back documentation and everything else, and then make all the changes in all the different databases to get those two pedons straightened out. And the longer we wait, especially those projects on microfiche, it's possible that those kind of problems might never be fixed. So it's good to try to keep these things straight. If you do find errors such as those that I just found, there's a way that you can actually load up your pedons in NRCS, run these reports, and send them into this center, and I would have updated that table for you. I think I showed this report a couple years ago in a webinar, and I've never had anybody take advantage of it, so chances are nobody will do it now, but I figured I should at least show you there is an opportunity to do so. But the lab layer table is controlled by somebody in the lab, and you can't get it changed unless you go through somebody that is an owner of that table. Okay. I have another little change of thought here. So where do we stand today? Well, a few years ago, the goal was to try to figure out how to capture the changes that the field made without relying on the field having to fill out a form and send it in. And so what we've done so far is we have made these reports. Site laboratory locations, overlaps, and classifications is the name of one of them. And it is used to extract the location and the classification from the RO-owned PEDON. As long as people keep their PEDON user PEDON ID straight and they put the lab sample number on the correct PEDON, then we can capture that information. Okay? As soon as you make a change in your PEDON, if it's the one that the lab is pointing to, you can immediately get a PEDON description with a point in the correct location. So that part is immediate. That report comes straight out of NRCS, and your change can be reflected in the PEDON description report. However, it can take 6 months to a year to get into all the different products from the lab, because we have to run the report and update different tables in different databases and then create new exports for the final product to end up in the reports. So after this 3 months or a year, if you look back at the database, you still might find your change didn't make it. Your point is still out in the middle of the ocean. Why is that? And the reason is because once we run the reports, we get the updates. Then we run them through a script that updates the database, and the script checks to see, oh, you've got an alphasol here, but in the order, it's a mollisol, but in the classification that you calculated, it's a alphasol. And if it finds those kind of inconsistencies in the data that it's importing, then nothing is imported, and so you don't get an update. So you need to make sure that your classification is consistent in all the sub-child tables, that you've done the calculation and updated your classification, and then your classification will be accepted as well as the new site location. So we've implemented the location and classification, but what we have not implemented were the designations of the depths that I just mentioned to you earlier. So what's the new vision? The new vision is we want those scan projects that I showed you an example of available. And we could put those in the enterprise content management system and allow people to go directly from the lab data to the project and find out why they sampled that PEDON. Okay. That also means that we would like to get the microfiche out of the basement and get them scanned before they get lost, because otherwise those projects will be lost. We'd like the method codes associated with each piece of data and linked to the description of the methods manual, so that we don't have people publishing research articles saying that, oh, this trend is happening because of all this data, and there was no trend at all. We just changed our methods, and the results either increased or decreased because of the method change. So we don't want those. We would like people to know what they're talking about when they publish our data. We'd like the morphological database available and easily linked to the laboratory database. And as I told you earlier, Jason Nemechek and Adolfo have been working on this project whereby they can send the record IDs out to NRCS in chunks and hopefully build an entire file geodatabase for our entire lab database in less than a day. And that will be a great savings, because remember, that's a day's time of the computer, or 6 hours, instead of 2 days of my time babysitting, loading 5,000 records at a time and downloading them, running reports, and importing them. We'd like an easy, cleaner database that has been scrubbed of values that do not make sense. So we need people to take ownership of the data. If they see stuff that's really weird, they can ask for a rerun. But if it's really, really weird, like a negative 200, minus 200% silt or something, we need to get rid of that. There's no point in it being in the database because it's completely bogus. We don't have many of those. My rule of thumb is it doesn't matter how big the project is, you get a handful of problem products. You can have 50 PEDONs, you get 5 problems. You get 500 PEDONs, you still have 5 problems. You get 5,000 pet-ons, you still have 5 problems. I'm not sure what this rule is, but it seems like there's just a handful that are an issue. And we need to find an easier way to upload university data and correct data that's previously been updated if errors are identified. You know, one thought was if eventually we actually add these tables to NRCS, maybe we could have a way that we could have them certified or uncertified for upload and actually give people the ability to add to those tables, and then a QA/QC process for whether we actually upload them or not. But that is after I'm retired, which is only 2 days from today. What kind of tools are available to help people use the database? We made calculations that mostly are used here in the lab. Some of them could be used in the field, or you could get training if you wanted to. But basically, they take text files that we build, and they add the sample numbers to the lab data. And like I say, if the joins are good, they are a lot more efficient, and there's less chance of error than hand entry. We also have calculations that can go into the database and find out which pet-ons should be linked to the lab data. So we'll update the record ID to our own pet-on. We then have another calculation that will take the particle size control section from that updated classification and put it in the table. And then we have calculations for the pet-on level calculations like LE, carbon clay, non-carbon clay, CE7 and clay ratio, those kind of things for the control section. And once again, we have more calculations for updating the sample numbers, horizon designations, and those kind of things. For reports and queries, we have reports that load 5,000 records at a time, which I hope we don't have to use anymore now that we have a better way of downloading the data. We won't necessarily need the Pet on PC download anymore for a couple reasons. One is that we can now do a lot of the calculations in R. And with NRCS 7, several statistical things there's several things available in NRCS now that weren't in the old NRCS. Once we get the new client out, they allowed like mean and standard deviation, those kind of things you can now actually do in NRCS, which you couldn't do previously. So if you have any questions, you can ask your RO for assistance for the sites. You look at your KSSL group where your pet-on is and find out who owns that group, and that's the person to talk to about changing ownership. If you find a site over in Oregon that belongs in Florida, you know who to call. If you have any pet-on problems, then Scarlett's name is in the table to move pet-ons. And the goal is to get people to take ownership of their data, and when they see something weird or wacky, to say something and get it fixed. Are we open for questions? Can we be?
Sure, we can be open for questions. So we'll give people online a chance to collect their thoughts and ask a question of Henry. While we wait, is there any questions from the room and here with me?
I don't have any questions, Henry, but that's pretty slick being able to get at the lab data in NRCS and on
Lab layer table?
Through the IDs and all that kind of stuff. I was able to get color data and organic carbon data for Kuchera like that. Although I did it kind of a clunky way, but I got it eventually.
I have a question or two. We have lab data.
Correct.
Generally tied to a pet-on.
Mm-hmm.
Hopefully we also have a pet-on description.
Correct.
not always, but hopefully. How easy is it to pair those and call those out, get them at the same time? Because oftentimes you need both.
So Henry, if you would kind of rephrase that question for everybody online, they can't hear it.
Okay. So Phil was asking how easy it is to link the morphological data to the laboratory data. That's the bottom line. In the past, I have created a Access database that has about 63,000 pedons, and that Access database can be used to link the laboratory data to the morphological data. When you go online, of course, you can download from the website one pedon at a time, the lab data and the morphological data, so they are linked there. I'm sure the goal of, Adolfo and Jason's download from the web, that includes both the NRCS, so the lab data that's in NRCS already is linked to a pedon, or can be linked to a pedon through the pedon record ID. So that is linked already in NRCS for NRCS users. And, now that we have, if Adolfo and Jason get their script running well, we potentially could supply a set of morphological data with the lab data. That's one way. And we've also talked about a web service, which we've been toying with. I think Dylan has got a web service already for a demo. But most of these things all require a little bit of skill in R or various applications. For the novice, the easiest thing is a pedon record ID, or a lab sample number. You put it on the web, and there's your pedon and description together. But that's one pedon at a time, or up to 200 pedons you can submit at a time through that service. Does that answer your question?
In part.
In part.
Yeah, so they're roughly 63,000.
There's 63,000 plus.
That have both lab data and description.
I would say that probably at least 10% of them or 15 are missing descriptions, probably, of those. At least that many. In NRCS, we call them, quote, skeletons, which basically means that we created a fake site and a fake pedon that's got the user pedon ID, user site ID, horizon designations, horizon depths, and sample numbers. That's all it contains, and that's just enough to get the data into NRCS. And there's no description. As the field comes across the real description for that particular, quote, skeleton, they will take that, that skeleton and they will flesh it out and actually populate a real pedon description for that one. But there's several thousand of those. There's no active directive to do that. I just know that people have done it because they've asked me about it, and I've helped them with it. And when people, the way that is set up in NRCS is the skeletons are in a group, which I add everybody that asks to the group. So anybody that wants to be added to the group has the ability to modify that pedon and move it into the appropriate location. And like if it was somebody from Massachusetts, they might move it to RO12. If they were in Oregon, they'd move it to RO1 after they filled out the pedon description. And
there's an online question. In the past, the university lab data was entered into the Lincoln Lab via Microsoft Access database. Is this still the process that the universities are to use, or is there another method to input their data?
The real question is who's going to do it when I leave. That's the real question. I've got 2 universities right now. I've got one project from Idaho, 65 pedons. I've got another project that I split in half for Iowa, I was able to get 141 in, and I've got 600 and something waiting that may or may not get in by Friday. But once I leave on Friday, I'm not sure who actually is going to be uploading University Lab data. The ideal, as far as the system to get it in, the best system is a clearly labeled Excel spreadsheet with method codes for each column, and put the data in, logical columns. And in the future, it's possible that more data will get in the database. I do know that in 1996, I was given a university laboratory project from Ohio. And I think in 1995, I was given one from Indiana and Illinois. And those made it into the database in 2010. Sometime in the last few years, I was given one from Florida, and we got it in less than 6 months. Some of the projects people send in, we've gotten in less than a week. So the question is, why is it that some projects take forever and others can get done in a week or less? And what it has to do with is sort of diligence on the part of the submitter. They need to have their pedons in NASS. They have to have their lab data in an Excel spreadsheet with sample numbers that match what they have in NASS. They need to have checked their data so that the sand fractions end up to total sand and the sand, silt, and clay add up to 100%. There's a couple other base saturation calculations. They basically have to QC their data so that it meets the minimum requirements. If they'd done all that and I was still here, we could get it in less than a week. I'm not sure who's going to do it after I leave on Friday.
Well, thank you, Henry, for your time and effort to make this presentation, and thanks to all the participants for joining in. We had more than 100 people join today's webinar. The on-demand recording of this webinar will be available on our National Soil Survey Center YouTube channel within a few days, so feel free to let your colleagues know about this training opportunity. This concludes our webinar presentation.